Okay. I'm going to repeat that since I started the recording. There are two parts to Lab 8. One part is optional and one part is not. The part that's not optional is in your lab packet. And the part that's optional, if you go to Canvas lab related files, you'll see a wet lab 8 aspirin acid neutralization equivalent. That's the part that's optional. If you want to do that, it'll give you an extra 5 points out of the 10. Basically, it's aspirin is also an acid at the same time. And what you can do is you can find out, you treat it like a regular acid and you do an acid-base titration against it, and you can calculate the molar mass. Then you compare that molar mass of your acid equivalent to the real molar mass, and the closer they are together, the purer your aspirin is. Now, in the past, that was not optional, and this year, because there was a change up on the schedule a little bit, I just wanted to make it optional. Okay, all right. Okay, any more questions about labs or anything like that? Okay, well, let's go ahead and do a review. Now, you may have one 3x5 card next week. And there will be two different tests, so the money people will not be getting a bump like they did on test 2. Okay, and this is under practice tests in Canvas. Okay, so as usual, there's going to be naming and reactions along with intermolecular forces. Okay, so what do we have here? Well, we've got a salt. And this would be the acid part. So to name that, you'd say, you name the cation first. And this is a 1, 2, 3, 4, 5. Actually, and it's got a ethyl branch, and it's a 5-carbon backbone. And because it's a sodium salt, we name it as a sodium 2-ethyl pentanoate. Okay, what have we got here? The next one here. And we've got an ester. And this is the acid part of the ester. Alcohol part. So we name the alcohol part first, which would be a methyl. And this is based on benzoic acid with no benzoate. Okay, we got another ester down here with some branching. Here is the alcohol part. So we name the alcohol part first. So that's going to be ethyl. And this is a 1, 2, 3, 4, 5, 6, 7. So it's based on heptanoic acid. And we've got a branch on 1, 2, 3, 4. So it's going to be 4, 4 dimethyl heptanoate. Okay, we've got a long fatty acid here. And I said you can name these using the IUPAC or the common name. Okay, the IUPAC, this is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So '20s Icosa. And we have at positions 1, 2, 3, 4, 5, we have 5, 6, 7, 8, 11, 14. Then we have 1, 2, 3, 4, 5. 17, and that's pentaenoic acid. And they're all cis, so we have 5 cis here. So over here, this should have had all the cis over here. Now, the reason why this table doesn't have the cis on it because all the fatty acids are naturally cis. But this would be the official IUPAC name. Common name would be EPA. So whenever you buy omega, and it's also an omega-3, let's just name all the parts here. So this is a 20 carbon fatty acid, 5 double bonds, and it's at positions 5, 8, 11, 14, 17. Notice these are 3 apart. Okay, any questions about that? Now this would be a good thing to have on your 3x5 card. Okay, draw the following structures. Okay, so we're looking at a six carbon acid. And we have it carbons 4 and 5, 1, 2, 3, 4, and 5 methyl groups as a branch. Okay, we have it acid salt. Okay. So we have a branch there. Okay, what is a wax? Okay, a wax is a ester, and it is very, very long. So you've got like 20 carbons, and this would be the acid, alcohol, and you can have a whole bunch over here. So you can have like 25. It always be an even number, say 26 carbons. And these numbers can be anything you want, as long as it's even and long. Okay, reactions. Okay, what do we have here? Basically, we have an ester, and this is the primary backbone, and this would be the secondary. So in my opinion, the easiest way to do this would be put the, as far as on the reactant side, would be just put them in that order. The alcohol first, then the acid. Normally, I put the acid first, then the alcohol. It doesn't really matter. So this would be the alcohol. And the acid is simply propionic acid. Oops. Now, to name this cyclic alcohol, it's going to be, and that's a 6 carbon. Six carbon alcohol. So that's cyclohexanol with a branch at carbon number 2. So 2-methyl cyclohexanol. Okay. Now to name the ester is going to be, we name the alcohol first, so it's going to be 2-methyl cyclohexanol. And then we name the acid part. And remember, there are 3 ways to make an ester. Okay, the acid plus alcohol. We have the acid chloride plus the alcohol. Then we have the anhydride plus the alcohol. 3 ways. This is usually the preferred way. This gives the most yield. And the anhydride gives you an intermediate yield, but it's got the best shelf life. The acid chloride is very unstable. That's why you get such a good yield. But because it's so unstable, its shelf life is very short. And because of that, it's very expensive. Okay, under pH 9. Okay, pH 9, that means it's alkaline or basic. And discuss the ionic or non-ionic state of cis-2-pentanoic acid. Okay, so let's draw it. Pentanoic acid, of course, is 5 carbons. And that is a trans, not a cis. So let's draw it cis. So this is trans. This would be the cis versions. Okay. Now, under basic conditions, that OH group is going to grab hold of this H here. That's supposed to be on here. That makes that an anion. So this would be the, excuse me, the acid salt. Now, if this was HSA2, then it would be protonated. You have an H on the ends here. Okay. Now you will have one of these questions. In fact, when we get into Unit 4, we're going to end up with the same situation, only with nitrogen compounds acting as a base. And those are opposite conditions in the pHs of the acids. But we'll talk about that when we get to the next unit. Okay, more reactions. Okay, so we've got an acid chloride and an alcohol. And now we are going to make an ester, okay? So we have primary, secondary backbones. So this is a 1, 2, 3, 4, 5. So that's going to be just like this here. And it's a cis. And this is 2 carbon. So to name this, it's going to be ethyl. And we have ethyl, cis, penta, no, wait. Now I make a point here. It says only use the reactions from class for full credit. Now, some people who have had organic chemistry in the past, um, there's a lot of ways to make esters and under different conditions, etc. Um, so I'm going by, I want you to use whatever is on the flow chart. And that flow chart, of course, will be given to you on the last page, just like the last test. Okay, make sure you abide by the cis-trans stuff. We've got, we have to name this. This is the ethanol. And this is going to be what we have up here. Should be cis. This is wrong, by the way. This should be enoate, not onoate. And it's on position 2. So this is going to be this is 1, 2, 3. I have it on 1, 2. There. And it's going to be 3. So this is going to be cis 3 and T, no, oh wait, yes. Okay. And again, pay attention to the cis or trans. Okay, so we have an ester here. Going on to the next one here. This is the primary backbone on the acid side. The alcohol side is here. And we're going to saponify it. In other words, we're going to hydrolyze this into in a alkaline or basic environment. Okay, so we've got a 3-carbon acid. So let's name that. And a 3-carbon alcohol. And we have a sodium propanoate. And then the naming the ester, that's going to be propyl for the alcohol, and then propyl 1, propyl, um, propyl, propanoate, propanoate. Okay. That's small. Okay, what do we have here? We have an ester again in acidic conditions. Okay, so let's name this ester here. Okay, it's got 2-carbon alcohol, 2-carbon acid. So the alcohol is going to be ethyl. Okay, or ethyl acetate. For our class, I just go with the IUPAC name, because otherwise there's a whole bunch of common names you may or may not run across. Okay, so in an acidic environment, we're going to hydrolyze that. So we have the acid, which is a 2-carbon acid, so it's going to be in an acidic environment, so it's going to be protonated. So that's ethanoic acid or acetic acid. This is ethanol. Okay, so let's look at the 3 ways to make this ester. Okay, so we've got 1, 2, 3, 4, 5, 5-carbon acid, 2-carbon alcohol. So let's do it the least effective way. So we need to combine with ethanol plus would be alcohol plus a 5-carbon acid. Okay, so that would be the least 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 yield. The most yield would give us same alcohol, and instead of the acid, we would use the acid chloride. Okay, and then the most common method is using the anhydride. Same alcohol. Remember, an anhydride is, think of it as 2 esters together. So one side is 1, 2, 3, 4, 5. One, 2, 3, 4, 5. And that would be dipentyl hydride. And then hydride I've seen spelled with 2 N's and 1 N. So use whatever version you want. Okay, so make sure you know this guy. That would definitely be on the test. Okay, so what's wrong with this? Okay, if you look on your chart over here, stearic acid is a totally saturated acid. It's particularly unhealthy. It has no double bonds, which is on omega 0. Octanoic, octadecanoic acid is the IUPAC name. And because it has no double bonds, there's no sister trans. And the delta is going to be 18, 0. And you can put a delta if you want in there with a 0, or leave it off, that's fine. So there's a lot of ways to correct this. One way is we could rename this oleic acid, which is 18,1 delta 9. We can name it 16 carbons long as fulminic acid. We can just rename it fulminic acid as well, only when you have to put the double bond in. So a couple different ways to correct it. And on the test, I would say what's wrong with it and correct it. And there's multiple answers for that. Okay, what's an emulsifier? Okay, to start with, molecule that has both nonpolar and polar areas. Give an example. Okay, so let's use lecithin as an example. That's one of the triglycerides, the phospholipids you need to know. Lecithin. Yeah, lecithin has got 3-carbon backbone. You have an ester here. Doesn't matter what fatty acid you have here. And you have another one over here. Okay, and then you have a and that is choline. And that is that. Okay, so I like the structures that make an emulsifier. Okay, so that's the polar part. These areas are the non-polar parts. We have a little review, name this. Okay, so we have a cyclohexanone. And that is always carbon number 1. We've got 2 branches. We have a methyl and an ethyl. So it's 3-methyl, 2-methyl, cyclohexanone. Okay, we have another ketone down here. It's got 1, 2, 3, 4, 5. So that's a 2. Pentanone. And it's got a branch at 1, 2, 3. Okay. And what's this guy here? Well, if it was just that, that would be amylose or starch, but we've got them branching it at carbon number 6. So that means that is an amylpectin. And some holdover reviews. So we have six carbon ketone, number 2. And we have a branch at 4. That's 1, 2, 3, 4. And at 3, we have phenyl. And at position 5, we have phenyl. Okay, so what do we got here? Labeled as a hemiacetyl or a acetyl ketal or nothing. So this is nothing. It's a plain old ketone. Okay, this has got OCO. Excuse me. It has a hydrogen here. And no OH. Okay, so one is going to be, and that'll be the anomeric carbon. Okay, so yes means it's going to be an acetyl or hemi acetyl, and because there's no OH there, it's just a plain old acetyl. Here we have OCO. I've got no H, and we have an OH, yes. So this is a hemi ketal. You know, this practice test has a lot of test 2 stuff in it. Your test is not going to have, it may have 1 or 2 questions from test 2, but not this extensive. Okay, So are there any questions about this?
I have a question.
Yeah.
So, I was looking at the schedule. It said that we'll have the test 3 online. I was just
Right.
wondering.
That's because you haven't downloaded the new schedule. I posted about 2 or 3 weeks ago. So it's an in-class test.
It's an in-class test, and that'll be on. Let's say if I'm having lab on Monday, it'll be on Monday then, right?
Yeah, it'll be just like we had test 2. Monday, Wednesday, in class, in the lab.
Okay, sounds good. And then you said how many flashcards can we have?
One.
One. Okay. Thank
One
you.
3x5, both sides though.
Okay. Awesome. Thank you.
Sure. Okay, let's review some more. And what we're going to do is let's look through some of these questions for another 10 or 15 minutes or so. I just want to recognize an organic acid. Okay. This is going to be an ether, alcohol, and aldehyde. And this is going to be the acid here. Okay, so this is a primary backbone, and it's an acid, so it's going to be 1, 2, 3, 4 with a ethyl branch on carbon number 2. Okay, so backbone, so it's based on benzoic acid, and 1, 2, 3, so it's going to be 3-methyl benzoic acid. And we've got a 3-carbon backbone, branch at carbon number 2. And okay, so this is an ester. So that one counts, that's an ester. This is an ester. Remember, the esters have to have the OH at the end. Okay, and this is an OIC, so it's definitely an acid. So C and D are both acids. Okay, so we have positions 1, 2, 3. This is 2 bromo, so 1, 2. So it's D. Okay, this is just information. Formic acid. Okay, oxalic acid is from spinach or nettles. And when you eat fresh spinach, you'll notice it has a slight kind of crunch to it, and that's the oxalic acid you're tasting and feeling. Okay. Why were the first organic compounds studied? Their abundance. Okay, what physical relationships are attributed to carbonic acids? Well, their pH is less than 7. high intermolecular forces. Um, they boil at high temperatures. They're soluble in water up to C7. Okay, so we go 1, 2, 3, 4, 5. Okay, so that's not written correctly. It should be 1, 2, 3 bromobenzoic acid. That's kind of, I would have said, what is the correct IUPAC name for a 5-ben bromobenzoic acid? Okay, first of all, we have acid, 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 alcohol. Okay, the alcohols are all lower than the corresponding acids. And this is not an acid, it is an aldehyde. So these two are definitely have less intermolecular forces than the two acids. And this is ketone. Gosh, Bert's and you're blowing it here. So the acid of all these is going to have the highest intermolecular force, hence the highest boiling point. Okay, now, if these were all acids, okay, so that's 1, 2, 3, 4. This is 3. This is 3 also, and this is 3. So between the two of these, which would be the highest one? This one, because it has more mass, more carbon. That's a C4, C3. Okay, most soluble in water would be the one that has the highest IMF. So acid, and this is alcohol, this is a ketone, and this is an ether. Okay, so acids have the highest IMF, so it would be D. Okay, at the beginning of the PowerPoint 2 weeks ago, when two acids are in a solution together, they can form something called a dimer. And that's what a dimer would look like. Okay, so we've got a 2-carbon backbone. So what you're going to end up with is a 2-carbon salt, which would be this guy here. Okay, so which of the following conditions would favor the carboxylic anion instead of the acids? Okay, so in high pH, that would take the hydrogen off, leaving the ion by itself. Okay, like this example here, this would be okay. So that there, and that would form water and leave you with the 3-carbon ion. Which would be better. Okay, so this is a saponified ester. So it takes it apart to the salt. Actually, let me back up. This is, we're starting with the acid, not ester. So basically, if we have that they're present from the sodium hydroxide, that guy and that guy come together to form the water. Okay, so let's name this guy. Well, first of all, it's got 1, 2, 3, 4. So it's 4-carbon. Um, primary backbone. And so we have sodium, and it's got 2 methyl butyrate. So we have 2 methyl butyrate.
Having the sodium in the front really kind of gives it away.
Do you have a question?
No, I was just saying like having the sodium in front kind of like gives you like a 50-50 chance.
Yeah. Yeah. So in this one, for example, those two would be immediately kicked out because you have to name the sodium first. So it's between the first or the second one. Same thing with this one. And we're naming a salt, so it's got to start with potassium, so that means that's out. Remember from that's meta. So it's going to be that. So it's going to be potassium. And because it's a salt, it's going to have the OH. Not these two. And I didn't stress this, but salts of short chain acids are frequently used as preservatives. Okay, which of the following is used as an ingredient in soap? Okay, well, that is an emulsifier. Stearate is comes from stearic acid, so it's the sodium salt. Stearic acid. So that's what one of the probably ingredients. Then you have glycol as well, but that would be basically what we did in our soap lab. Okay, the sodium salt of benzoic acid is called sodium benzoate, and sodium benzoate is used all over the place. The problem with sodium benzoate, by the way, is it's easy to convert. So this is what sodium benzoate looks like. So in an acidic environment, that would turn to benzoic acid, because that would protonate that. And benzoic acid can be converted to benzene enzymatically for certain bacteria. Benzoic acid happens to be a very bad carcinogen. So that's one of the issues with sodium benzoate as a preservative. Okay, so we have an acid and an alcohol produces an ester. Okay. Whenever we oxidize so this is a 1, 2, 3, 4. Four carbon acid. And with a branch on carbon number 3. So what makes this basically is what they're asking. What do we start with? Well, none of these are branched. They're all 4 carbon. Well, these two are 4 carbon, C and D, but A and B aren't even 4 carbon. So those two definitely. And this has no branch. So the only one left is D. So here we have acid, alcohol, acidic condition gives us an ester. Okay, so what does that look like? Well, line drawing wise, it's kind of weird. It looks like this. So it'll be, the name would be methyl. Either form like formic acid or methanosate. Okay, so pleasant characteristic odors, aldehydes, esters. So C or D would work. Okay, so we start with four carbon, two carbon alcohol. So what is that going to look like? It's going to be so it's going to be ethyl and 1, 2, 3, 4. Okay, methyl means it's got a 1 carbon, comes from a 1 carbon alcohol, and an acetate is 2 carbons. So that's 3 carbons, 1 carbon, 2 carbons. So ethyl stearate. Okay, hydrolysis means it's going to come apart. Okay, so we have ethyl. And stearic acid is 18 carbons long. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 15, 14, 15, 16, 17, 18. Okay, that's C18, I think. Okay, hydrolysis, that means you're going to have the alcohol plus the acid. Which would be that guy there. Get a common name. Well, first of all, looking at this, so this is going to be from the alcohol, ethanol or ethyl. So that means those two are out. And we have a 1, 2, 3 carbon acid. So it's going to be that. So that's C2. So that's out. And that's C3. Okay, so we have methanol and benzoic acid. Okay, so we always name the alcohol first. So that means that's out and that's out. So it's either methyl benzoate or methyl benzoic acid. And because it's an ether, I mean, it should be an ester, it's got an O8 ending. So that means that's out. Okay, so sponification. So chemical reaction results in saponification of an ester. So A would work. It's in a basic environment, not an acid environment. and it forms the alcohol plus the salt. So it's not C, by the way. Um, and it could be D. So really the answer is A. Okay, so IUPAC name for this. Okay, it's an ester. So that's the alcohol. And this would be the acid. 3 carbon acid, 2 carbon alcohol. Okay. Those are both 3 carbon alcohols, 2 carbon, 2 carbon. We want 3 carbon acid. So it's going to be ethyl propanoate. Okay, so this is the alcohol acid. So what are we starting with to give 2 carbon? 1, 2, 3, 4. 4 carbon alcohol. Okay, so the alcohol is over here. 1, 2, 3, 4, that's 4 carbons. And this is not an acid. Got to start with the acid end here. Okay, so we have 1, 2, 3, 4. That works. And we have a 2 carbon acid, so that actually would work. Here we have a 2 carbon alcohol. We want a 4 carbon alcohol. And this is a ketone, so that's not going to work at all. So the only one that's even feasible is B. Okay, it's an ester. I'm going to saponify it. Saponification gives us the alcohol. And 2 carbon acid. Okay. So we need a 2 carbon acid. And because it's in an alkaline environment, saponification gives us the salt. This is the acid, which would be in a low pH environment. This is a 3 carbon salt. So that wouldn't work. And then we have just a plain alcohol, and that's not going to work. Okay, so obviously it's C. Okay, again, we have an ester. Okay, so that's 3 carbon, 2 carbons. So this is the alcohol, that's the acid end. So first of all, which one of these have got a 2 carbon alcohol? Two carbon alcohol right there. And this is 2 carbon. This is 3 carbon, 2 carbon. Okay. And that's not an alcohol. And that's not an alcohol. So the only alcohols are these two. And those both work. And because it's an alcohol, I mean, an alkaline solution, we have saponification. So that gives the salt plus the alcohol. That's not. Okay, so we have saponification requires pH greater than 7, and because we're in an acidic environment, that's not modification. Dissociation means we start with an acid, and this is an ester. So that's not that. And we're already starting with an ester, so it's not esterification. So the only thing left is hydrolysis. So whenever we have hydrolysis, meaning water, in an acidic environment or a alkaline environment, the ester comes apart. So it's C. Okay, esters need acid plus alcohol. Okay, and because it's a phosphate ester, we're going to start with phosphoric acid. Okay, and so phosphoric acid and carboxylic acid is not going to work. We need an acid and an ester. And here we have an acid and an ester and phosphate. So the only one left for acid plus alcohol is A. Okay. So we need, again, acid plus alcohol. Okay. That fulfills the alcohol part. So acid, 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 so they all work. B. Okay, this is an acid, this is an ester. And we have another ester. Okay, this is an acid here. This would be 1, 2, 3. So this would be 3 bromo. And this would be 2 bromo. So we want 3 bromo. Someone wants attention. I have 2 dogs at my feet right now. Okay, I'm going to go over one more example, and that's going to conclude our review. Okay. All right, so we have bromomethyl. Okay, so this is an ester. Okay, so that's an acid. This is an ester. This is an ester. This is an acid. So there's definitely not the acids. Okay, so methyl, bromomethyl, that means the bromo is with the alcohol, not the acid. Okay, in this case, the bromo is with the methyl. In this case, the bromo is with the acid side, so this is not it. Okay, so that was been a pretty good review today. This would be a good video to watch a number of times. Okay, are there any questions about anything? Excuse me. Okay. So any last minute questions? All right. I have all your graded tests. I'll have them with me. And feel free to go through them and correct them. And if you want to correct your mistakes, I'll give you half credit back. And you're going to be working in twos unless there's an odd group. Now, I don't want you working by yourself in lab today. This is definitely a 2-person or 3-person lab. Okay, nothing more than 3, and that's only if we can't come up with twos. Now, if you're by yourself and you know your lab partner for sure is going to show up but late, that's fine, but no singletons, okay? All right, any other questions? You'll like the lab today. Most people did. So, all right. Well, I guess I'll see you guys later today. Take care, all. Nice day.
Thank you. See you soon. Bye.
Thank you, Professor.
Oh, Professor, just a quick thing. You're okay with us like if we're on Monday lab working on Wednesday, right? Like, you've been okay. I'm just gonna make sure check that in.
So you're saying it's okay if you show up Wednesday rather than Monday?
Yeah, so like my partner, she's out because of I think strep, I believe. So yeah. Anyways,
And your partner is
Addie?
she's the redhead, right?
I believe so. Sorry. I don't particularly remember her. I think she's yeah.
It's Addison, right?
I believe so. Yeah.
Yeah, she's the
Yes.
redhead. Yeah. I was
Yeah,
talking,
sorry.
I
I
was
think
talking to her about how to get red hair if you're a brunette, and so we were talking about all the chemistry and stuff. Yeah.
oh yeah, that's gotta be pretty cool. Anyways, thank you, Professor.
Good project too, by the way.
Yeah, for sure.
Beth, do you talk with her regularly?
Yeah, I text I'm in yeah, I could text her. Do you need to pass anything on?
Well, you could say as a project, she could talk about, process of hair coloring through dyeing,
Oh yeah.
because you talked about it a fair amount. So, and she seemed interested and she may have another project already going.
Oh yeah, I don't think she has one. We were talking about like what to do. That might be a good idea for her to do.
Yeah, well,
But then you have to make a poster too, right?
yeah. Think of it's a 1,000-word essay, and then there's a poster. And the poster, think of it as the media from your essay.
So I just had a quick question about the poster. It's not poster, sorry, the essay. There I couldn't really find like a prompt in term. So we figure out whatever thesis we want to like write, right? Or should I think about this as like you're trying to promote this whatever this chemical slash thing. You just want to educational like you want to educate people about it, right? Like that's how you're writing about it.
Yeah, just to start, for example, let's dye some hair. Well, the first thing you need to do, if your hair is too dark, you have to bleach it first. Okay, and how do you bleach hair? And then there's that process. Okay,
Okay, got it.
and then
Okay.
if you're going to dye it, then you've got to combine it with some kind of a dye that will attach to the protein follicle, which is
Right.
which is known as hair. I mean, so you'd have those steps, and you just kind of explain it all.
Okay, I appreciate it, Professor. Thank you for the
And then
quick-
if it's a drug or something like that, you can talk about pros and cons, and then how it reacts.
Oh, very exciting stuff. Okay.
Yeah, it's very loose, but I want you to have something organic and/or biochemical.
Yeah.
Okay, sounds good. Does that make sense?
Yep. See you soon. Bye-bye.
Okay. Cool. All right. Take care, you guys.